Welcome to clickmyproject.com. Our product title is OTA-based logarithmic circuit for arbitrary input signal and its application. Now we are going to discuss about our product abstract. In our process, we mainly using for designing for circuit analysis using the CMOS technologies. So main operation for operational trans conductance amplifier OTA. It's like act on the regulator. Regulator means use a boost and buck and boost the regulating, amplifying the sensing the analog inputs of the process. So, and then we have mainly using the Tanner software tool and consist of CMOS technology. So CMOS having that PMOS and NMOS transistors combinations and act on the amplifiers. We can give the analog inputs of in case PMOS or NMOS transistor, the NPN transistor of the voltage sensing the process. We can give the any input analog signals with amplifying the and boosting the waveform of the signals. And mainly we focused for the amplifiers, they like class AB type of amplifier. And then we using the PMOS and NMOS, the connecting pair of some front end and back end of transistors. It consists of the PMOS and NMOS technologies, having the more efficiency in the PMOS technologies. And then north and south we can using the P and NMOS to consist the three drain and source gate. So we can connecting the, as further we design the OT generation amplifier circuits based the full and full we are using the designing tool. And then a Tanner having the three inbuilt of the tool, T-space and W-edit waveform the process. And then we can analyzing the power analyzing using the T-space tools, and timing also, timing and frequency speed all are calculating in the inside the commands using the T-space tool. So after considering that analog in front end circuits, we using the PMOS, and then the read the output in the amplifying the circuits, we get the input the signals, we getting the reading the signal. So write and read the signals, both we have using the PMOS and NMOS technology in the Tanner's design. Now we are going to discuss about our product flow diagram. In our process we can using the Tanner software tool and input signal for the voltage or pulses, whatever we can using that. Here we using the input bits. So we can using the pulse based the high and low 0 1 0 something, we can give the input pulses. And then designing for the OTA based the amplifying circuit based on SRAM, static RAM, bit based the PMOS and NMOS cell group of designing. After we using that, the combination of SRAM have like that 60 70 80 10 some number of T transistor based, we are using the SRAM bit group of cells. After we using the input signals, we read and write path. So we give the input signal reading the path, the same time we analyzing the sensing the process selection bit based, we are getting the writing path. So what we are giving the like that 1010 is the like input signal, we getting the digital wise the 5-volt power supply, we getting the output of the writing path. The same time the leakage current is occurred in this based on the selection process. So how we reduce the leakage current in the process out based on the address selection process. So finally we store the data in the end of PMOS and NMOS, the write and reading path. So we reading path we optimize, and then same time we getting the what we give the input same like we getting the amplifying the signals. So input signals is reading the analog waves and getting the output for digital waveform in the final output storage the functions. Now we are going to discuss about our product running procedure. In our process, the ADC and interfaces sensor interface application based on designing using the Tanner EDA tool software. So we are having that some parameters values, and having the CMOS technology based, we are convert the analog to digital converters. So we use the CMOS consists the PMOS and NMOS connectivity of the process. So mainly the comparator and sample and hold circuits mainly using for PMOS and NMOS processes based. Here after complete the designing based on the ADC process designing circuits, we complete the sample and hold and comparators and multipliers and the digital output of the performance we are getting from this design completely. We go into the running the some procedure. Here we have set up for this Tanner simulation process. The transient Fourier analysis is very important for this process. We are enabled to the transient Fourier analysis. After we give the sum inputs, we should give the sum based on these parameters values, based on the so clocking pulse and the transmitter of the waveform. We getting the waveform edit waveform based on the circuits. So we should give this parameters values mandatory. At the same time, we give the some setup simulation process. Here the simulation for the library file, so main parameters for the library files, where we getting the source file or source um, library in our Tanner tool process. We are getting the setup path for the library models generated in the library TT format. So after complete this process, just running the process, so this start the simulation process, we are getting the two type of output simulations. So W edit is a waveform, graphically we getting the output. After same time, this is the W edit waveform. So this is the output for the analog to digital output process. So here digital outputs, we have zeros and ones. This is analog inputs, output for the digitals. So and then we have automatically open for the T-Spice. Here the T-Spice mentioned that so each and every process the timing for the performance level. So this is the seconds of the process. We have getting the some parameters for our processing the output files. After we giving some input for the output power, how to calculate the power calculations. Here some performance, how we are having our process, the time step and integration equation of the process. We have the performance based, we are getting the some result both the nodes and the devices, number of devices and active and passive devices using this simulation of the process. So this is the performance of our process. Here the all devices and node count of the process. So the loss, the delay timing of our process, then generating the setup of our process. Okay, thank you watching our video.